Welcome to the class. Myself Ashwini. Last class we have discussed about binary distribution and binomial distribution. In binary distribution we have studied the features, problems, 2 marks problems, all those things. In binomial distribution we have solved some problems, and today again we are continuing the binomial distribution with some other problems. In a college, 70% of the students are boys. Okay? In a random sample of 5 students, find the probability of getting, first question, 4 boys, second question, at most 2 boys. This is the problem. In the college, 70% of the students are boys. In a random sample of 5 students, find the probability of getting 4 boys, at the most 2 boys. Let x is number of boys selected. Since x is a binomial variate, so it follows binomial distribution with, and x is number of boys selected, and small n is nothing but a random sample is nothing but n, so that is our 5, and p, small letter p, is 70% of the students are boys. Here also we want to find the probabilities of boys, so here also they have given about boys, so p is 70%, or it can be written as 0.7, and q value is, this is our solution, q is 1 minus p, 1 minus 0.7, it is 0.3. Next, then x will follows binomial distribution with n is equal to 5 and p is equal to 0.7. Next, write down the PMF of binomial distribution. It is p of x equals ncx, p power x, q power n minus x. X takes the value 0, 1, 2, etc. n. 0 less than p less than 1. Q is equal to 1 minus p. This is the complete PMF of binomial distribution. And our first problem is we have to find a probability of getting 4 boys. So, probability of getting 4 boys means x equals 4, and we know the n value, x value, pq value, substitute everything in the PMF, then it is 5c4, p is 0.7, power x is equal to 4, q is 0.3 to the power n is equal to 5, 5c4, and this is 5c4 is 5 into 0.7 to the power 4 is 0.401 into 0.3, and this is probability of x equals 4, or probability of 4 boys is equal to 0.36015. 0.36015. Again I repeat the procedure. After writing this PMF, we want to find the probability of 4 boys, that is x equals 4. So this is probability of 4 boys, x equals 4. Substitute x, n and pq values in this PMF. N is equal to 5, so 5cx, 5c4, x equals 4, P value is 0.7 power 4, x equals 4, and Q is 0.3, n is equal to 5 and x equals 4. After simplifying this, you will get the probability of 4 boys. Next question is probability of getting at most 2 boys. At most is nothing but less than or equal to, okay? At most is always less than or equal to. So probability of x less than or equal to 2. Less than or equal to means this is P of less than 2 is 0 plus P of 1 plus equal to is there, so P of 2. So we have to find the probabilities for P0, P1 and P2, then we have to add that. So I'll write like this. It is 5C0, 0.7 power 0, 0.3 power 5 minus 0 plus 5C1, 0.7 power 1, 0.3 power 5 minus 1 plus 5C2, 0.7 power 2, 0.3 power 5 minus 2. So next step is simplification. 1 into 0.00243 plus 5 into 0.7 into 0.0081 plus 10 into 0.49, 0.027. So I'll write everything in the bracket because plus is there in between. Now you should add this. It is 0.00243 plus 0.02835 plus 0.1323. So probability of x less than or equal to 2 or at most 2 boys is 0.16308. 0.1608. Since this is at most problem, at most is nothing but less than or equal to. Less than is there. Less than or equal to 2 we have to take. Less than 2 means 0 and 1 and equal to 2 it is 2. Substitute P, Q and N values in the PMF for different x values. You will get the value. Next problem. The probability that a bomb hits the target is 1 by 4. 5 bombs are aimed at the target. Find the probability that first question, 3 bombs hit the target. Okay, and second one is at the most 2 bombs hit the target. Okay, since this is a binomial distribution, because here n equals 4 and hitting of target is 1 by 4. Okay, and we have to find the probability that 3 bombs hit the target and at the most 2 bombs hit the target. Solution: let x is number of bombs hit the target, hitting the target. And here n equals 5 because 5 bombs are there, n equals 5, and P, probability of hitting the target is 1 by 4. Q is equal to 1 minus P, this is 1 minus 1 by 4, or it is 3 by 4. So your X follows binomial distribution with N is equal to 5 and P is equal to 1 by 4. Next is write down the PMF. P of X equals NCX, P power X, Q power N minus X, X is 0, 1, 2, etc. N, 1, 0 less than P less than 1, Q is 1 minus P. And our first problem is to find the probability that 3 bombs hit the target. So probability of 3 bombs hit the target. That is P of X equals 3. If 3 bombs hit the target means X equals 3. Substitute that. So P of X equals 3 is equal to 5C3 1 by 4 to the power 3, 3 by 4 to the power 5 minus 3. 5C3 is 10 into 0.1015625 into 0.5625, and this is 0.0879. This is our probability of X equals 3. If 3 bombs hit the target, this is the chances of or aiming the target. And next one. At the most, second problem is at the most 2 bombs. Again it is at the most, probability of at most 2 bombs. Since this is at most, this is probability of X is less than or equal to 2. Since this is less than or equal to 2, we can write this as probability of X less than or equal to 2 is P of 0 plus P1 plus P2. This is 5C0, 1 by 4 to the power X is 0, 3 by 4 to the power 5 minus 0 plus 5C1, 1 by 4 to the power 1, 3 by 4 to the power 5 minus 1 plus 5C2, 1 by 4 to the power 2, 3 by 4 to the power 2, 5 minus 2. So that you will get the values like this. 1 into 0.2373 plus 5 into 0.25 into 0.3164 plus 10 into 0.0625 into 0.4219. This is 0.2373 plus 0.3955 plus 0.2637. So at last this is probability of X less than or equal to 2 is 0.8965. So probability of at most 2 bombs hit the target is 0.8965. Next one. In a college, 35% students are girls. Find the probability that, first question, 2 are girls. Second one is at least one is a girl. At least one is a girl in a random sample of 5 students. A random sample of 5 students. Here you just observe they have given the data about the girls. In a college 35% of the students are girls, and here we have to find the probability of girls only. 2 are girls, at least 1 is a girl, and random sample of 5 students. Okay. Solution. X is number of girls selected, and n is equal to 5, random sample 5, and p is equal to 35% or 0.35. Q is equal to, directly I am writing the Q value, it is 0.65, so that X follows binomial distribution with 5, 0.35. Next, write down the PMF. P of x equals NCX, P power x, Q power n minus x, x equals 0, 1, 2, etc. n, 0 less than p less than 1, q is 1 minus p. In each and every type, when we solving the problem, write down the PMF so that you can remember that PMF. And here first problem is probability of 2 girls. This is P of x equals 2. This is 5C2, 0.35 to the power 2, 0.65 to the power 5 minus 2. This is 10 into 0.1225 into 0.274625, 0.3364. This is probability of x equals 2, or probability of x equals 2 girls. Next is, okay, I'll solve this one here only. Second one is at least 1 is a girl. At least 1 is a girl. That is probability of at least 1 girl. At least 1 girl. This is nothing but probability of x greater than or equal to 1. Since I have n equals 5, if I take greater than or equal to 1, so I have to calculate the probabilities from 1 to 5, that is P1, P2, P3, P4 and P5. Instead of that, I will take the contradiction. This is 1 minus P of x less than 1. Here already less than or equal to, greater than or equal to is there. So equal to is there, so I will not consider equality here. I will just take less than 1. So this is 1 minus, less than 1 is 0, that is P0. This is 1 minus, for P0 it is 5C0, 0.35 to the power 0, 0.65 to the power 5 minus 0. This is 1 minus 0.11603. This is 0.88397. This is probability of x greater than or equal to 1. Whenever it is at least, it is better to take 1 minus of that. It is better to take 1 minus of that, so that our problem will be easier. In binomial distribution, we know the n values so that we can find all the n probabilities. But in Poisson distribution, when we come to Poisson distribution, it is very difficult to find the values. For that sake, we have taken for at least, always we will take 1 minus of that. Okay. Next one. In a certain school, 40% of the students have opted for first language Kannada. First language Kannada, assuming 20 teachers take a sample of 4 students each, how many teachers will report that 2 or 3 students have opted for first language Kannada. Okay, this is a problem they have given. Here in a college 40% of the students have opted first language Kannada, and 20 teachers are assuming taken a sample of 4 students each. How many teachers will report that the 2 or 3 students are opted first language Kannada? First we will see this. Here they are asking for how many. Okay, how many teachers? This is very important. So here X is number of students, number of Kannada students. Number of Kannada students. And N is equal to, and they have taken a sample of 4 students. N equals 4, and P is equal to 40% of the school, that is 0.40, and Q is 0.6, and here 20 teachers they have taken. So this 20 is our capital N is equal to 20, and here X follows binomial distribution with 4, 0.4. Okay, next write on the PMF. P of X equals, X is NCX P power X Q power N minus X. X takes the value 0, 1, 2, etc. N. 0 less than P less than 1. Q is 1 minus P. And here we want to report that 2 or 3 students, that is probability of 2 or 3 students. 2 or 3 is there, or is nothing but our addition in probability. So probability of 2 plus probability of 3 we have to calculate. So this is 4C2, 0.4 to the power 2, 6 to the power 4 minus 2 plus 4C3, 0.4 to the power 3, 0.6 to the power 4 minus 3. I'll write this in a bracket so that it is easy. This is 4C2 is 6 into 0.16 into 0.36 plus 4 into 0.064 into 0.6. This is 0.3456 plus 0.1536. This is equal to 0.4992. So probability of 2 or 3 students is equal to 0.4992. Since they are asking not only the probability, they want that how many teachers will report that. Many means how many, if they are asking about how many students, that is numbers, so we should multiply this obtained probability for 2 or 3 students with n value. Here we know the n value, it is 20. Okay. So among 20 teachers, this is 20 into 0.4992, this is 9.9884, so approximately 10 teachers. Okay, approximately 10 teachers, they are reporting that 2 or 3 students have opted first language as Kannada. If they are asking about how many and number of, at last you should multiply that obtained probability with capital N value. Capital N is nothing but a population. That value, that number we should multiply with the probability, so that we will get the number of teachers. Thank you.